So in this video, we're going to be discussing the routing pattern. So let's say you're a top businessman, making a lot of money, live in a very big house. You have a lot of things that you would like to do. You want to make sure that your clothes are dry cleaned. You want to make sure that your flights are booked. You want to make sure that your gardens are trimmed, your dogs are walked. And if you have kids, you want to make sure that you are always booking your nanny to take care of your kids. Now, to do all that, you will probably need a personal assistant. And this personal assistant knows all your workers. So they know this guy that takes care of your laundry. They know this guy. Let's just copy his stuff. They know this guy that helps you with your flight bookings. There's also this lady that helps you with your finances. And they also know another lady who is your lawyer. So they know all these guys, all these people that help you get things done. So you have your personal assistant here. Let's say PA. You have your personal assistant. This is your laundry guy here. This is your booking guy here. Your accountant lady here. And your lawyer lady here. So they know all these guys. You don't need to worry about all these guys. They know them. So your function is to give them a task to do. Oh, I want to go to so place, and I'm going to be flying there. So they know that this is a job for the flight booking guy. Yeah, this is a job for the flight booking guy. So they contact the flight booking guy with the details, and he books the flight. Then you ask about your income for the month. They automatically know that it has to go with this person. It has to go to this person. Any legal request has to go to your lawyer. And anything about what you're going to wear the next day and all that has to go to your laundry guy. So they know all this. Your PA is functioning as a router or router, depending on how you pronounce it. Your PA is functioning as a router. And they can go to any of these nodes. Let's make them checked nodes. They can go to any of these nodes based on the task you want them to perform. Based on the task they are given, they can go to any of these guys to perform the operation. They don't get to execute all these guys at once. No, they can execute two based on the request. Like, let's say you're traveling. They can, oh yeah, you need to book a flight and you need to have your clothes dry cleaned. So the laundry guy and the booking guy, they are going to have to do that. So they don't go through all parts. They just go through the part that has to do with the tasks you want them to perform. That is how routing works. It creates this decision tree where different inputs flow through different parts through the system. That's basically how it works. And these are conditional edges. Because they would only be traversed based on the type of task you have asked your PA to perform for you. So based on the task that you give to this node will determine what or where the router is going to send that information to. It's going to send that task to. So you have your router here. This is the starting point of your workflow. It analyzes the input and determines which part it should take. Then based on that input, the task, the content type, intent, urgency, topic, category, or whatever criteria, it routes it to any of these guys that are available in your pool of workers. Now, this component is always going to need a structured output because it is going to need a very defined way of knowing what the task is and who to send it to. So this is going to have an LLM that's going to be augmented with structured output so that when it takes the task can be interpreted to any of these guys and it can be able to send the task to these guys using a structured output. Then, like I said, these are conditional edges because they will not always be traversed. They will be traversed based on the task that comes in. So they are traversed conditionally. And also, these are specialized nodes. They perform one single task and they are independent. Don't make them depend on each other. They must not depend on each other. They are all independent. And each node contains logic that is tailored to the problem it's supposed to solve. Now, with these guys in place, you can choose to have an optional aggregator. You can always have an aggregator that probably asked to take on to the next step, because you can actually follow on the process. If you are done with laundry, you can actually just continue to the next node and keep going. So you can have some sort of aggregator or a fallback path for any task that is not included in the pool of tasks. You can have a fallback task. Maybe it will have to route it to another system or to another agent entirely. So that's how routing works. Now, what are the benefits of using the routing pattern? First, it enables specialization. You can have nodes that are specialized for individual tasks. A node to perform this operation, another node to perform that operation, another node to perform that operation. So you can specialize. Another benefit is that it improves efficiency. Why? Because you only have to move through the nodes that concern the task. You only have to move through the nodes that concern the tasks. You don't have to go through any unnecessary part. You move through the part that is concerned with the task that you want to perform. Also, it encourages modularity, as your nodes are specialized, just as in the parallelization workflow. And also, you can just break down any type of system into individual specialized workers, and your router is going to perform the work of making the decisions. Your router is going to make the decisions for you. So those are the benefits. Now, what are the use cases where we can use this? What are the cases where we can use this workflow, the example real world scenarios? First is a customer support system. Customer support system. This is awesome for a customer support system, because the router can categorize questions into billing, technical support, refunds, general inquiry and stuff. And when it receives a ticket, it will just route to the particular node that is to take care of that particular problem. It will just route to that node. So if it's a billing issue, it's going to route to the billing node. If it's a technical issue, it's going to route to the technical node. And you can create different response templates based on each category. Very fantastic use case. Another use case is document processing. Document processing. Now, oftentimes, you get different types of documents. It can be invoice, can be contract, can be email, and all that. So the extraction and processing logic for each of these type of documents is going to be different. So you can have a router that will recognize the type of document and route it to the appropriate handler. It detects the document. Is it an invoice? Route it to the invoice handler. Is it a contract? Route it to the contract handler. So that specialization and routing logic is just awesome for this particular use case. Another one is a medical triage system. So you have a medical system. It's a medical triage system. And with different categories: emergency, routine checks, urgent, emergency and urgent kind of fall in the same category, or some people that just want to come and make inquiries. So you can route to the appropriate care level based or information resource. You can sometimes you can just send some people to some sort of documentation or some sort of advisor that will advise them on their health. If it's an urgent issue or an emergency, you route them to the emergency section. And if it's a routine check, a regular doctor can take care of that, and they can always stay on the queue. So based on whatever issue they come with, you can use this routing logic to manage the whole chaos. So we now understand how routing works. The next thing is to see it in action. In this video, we're going to be designing the customer support system that we described in the concept section. We'll be using the routing workflow to build a customer support workflow that has different categories. One category for billing, one for technical issues, another one for refunds, and one for general issues. Any issues that don't fall into billing, refunds, and technical issues will be sent to general issues. So your router is going to take the user's request or the customer's request and route to the relevant handler. Then each handler is going to process the task given to them and generate an appropriate response for an email that will be sent back to the user that submitted the ticket. If that sounds fun, let's get started. First thing we're going to do is bring in our dependencies. So LangChain OpenAI, import, chat OpenAI. Then we bring in our graphing tools from langgraph.graph. Import state graph, start and end. Then from the typing package, we import our typed dict and literal. You'll be seeing why we need literal later. Has something to do with the routes we want to navigate to. Then for our structured output, because as I said, the router has to produce a structured output. So for that, we need Pydantic. And from Pydantic, we'll be importing base model and field. So we have our dependencies in. Next thing we need to do is define our state schema. So we're going to say class support state. Then inside here, we're going to have a customer query key to collect our customer query. Then we're going to have a query category channel to determine what category we're going to be routing to. Then response is going to be whichever output is generated by any of the nodes that we routed to handle our request. And then we have tools used. And tools used will just tell us anything that was used to satisfy the request. This is just going to be a dummy list we're going to be populating, and it's just going to be the tools used by the particular handler to handle it. For example, let's say for the technical handler, we can say we access the bug report, we can say we access the log files and stuff like that. So that's just going to help us make it better mirror a real world scenario. So with this state in place, let us get our model set up. So have our model in place. Now the next thing we're going to do is to define the model for our structured output. Just going to put a comment here and say define structured output for classification. By the way, another name for the router is the classifier. It classifies the requests, but everybody just calls it a router. So that defines its general process more. So let's define the structured output for that, the schema for that structured output. I'm going to call it query classification. Pass it the base model. Then inside here, the first thing we want is category. And that's what we're going to set to literal. And to contain all our categories. We have billing. We have technical. We have refund. And we have general. Then another thing we need, just for the model to tell us the confidence level it is working with, to pick the particular handler it has decided to pick as the one to go to. So why are you picking that particular handler? So let us write a description for that. Description equals confidence score, starting from 1 to 10. Or rather 0 to 1. 0 to 1. So on a scale of 0 to 1, 0 0.5, 0 0.9. Yeah, that makes more sense. So also, what's the reasoning behind what you selected? What's the reasoning behind selecting that particular handler? Because we need to be sure about all this, or at least know why certain decisions were made. So description, we say why this category was chosen. So yeah, these are the three pieces of information that we want the router to return. The category it wants to select to handle the operation, the confidence level of selecting that category, and the reasoning behind it. So we have this in place. Next, we're going to be creating our nodes. Now for the router node, I'm going to call it the classifier or the classify query node. You can choose to call it anything you want, but just giving it a name that kind of describes what it does. You can call it router, you can call it route to handler. Just give it a very descriptive name that describes its function. So here we say state. Oh yes, we already have state, so let's just get the type. So support state. That's what we'll be returning. And inside here, I'm going to add a print statement. Add a print statement and just say router analyzing customer query. Analyzing customer query. Good. Then we're going to say our classifier LLM. This is where we augment our LLM. We need our LLM to perform a structured output generation. So we can't just use our LLM directly. So we need to augment it. So I'm going to take the LLM and say with structured output, just as we did in the structured output lesson. And then we can pass it our query classification model. Yeah, that's what we're going to do here. So we now have an LLM that can take whatever comes from the user and be able to generate these pieces of data that we're then going to use to make a decision on our conditional edges to route to the appropriate handler. So we have our LLM. Next is the prompt that is going to instruct it. Just as I've been doing so far, I'm going to bring the prompt in, explain it so that we can move on faster. So prompt copied, paste it here. It says classify the following customer support query into one of these categories: billing, questions about invoices, payments, charges, pricing; technical issues, bugs, feature problems, integration issues; refund requests, returns, cancellations; account access, password reset, profile changes, login issues; then general questions, feature queries, information requests, and so on. And we get the customer query from our state. And it says classify accurately based on the primary intent. As you can see, the categories we gave it are the same categories in the literal definition here for the category field in our structured output. So make sure that that is consistent. So once we have this, we can then invoke the prompt with our classifier LLM. I'm just going to say classification equals classifier LLM dot invoke, and we pass in the prompt. And so that we can see what happened in our classifier, what decision was made, I'm going to add some print statements here. So say the category outputted will be classification dot category. Just going to copy this and duplicate it twice. So we have category. Next is confidence. And that will be confidence, and we just format it to have 2 decimal places. Then finally we have reasoning. That will be classification dot reasoning. We have reasoning. So yeah, we can just use this to see what is going on in our router. So put a new line there, and then we can finally return our query category, which is the most important thing in our routing operation, and just simply return this classification dot category statement. So yeah, now we have been able to determine our category because that is going to inform the node that we're going to go into. This will be returned here, and we can then use our conditional edge to check and route. So we have this in place. Let's with that. I think I need. Okay, I'm out of the function. So yeah, we have that router defined. The next thing we need to define is the billing. What is going to handle the billing for us? So for that, first I'm going to say print. Oh, sorry. I think I didn't define. Sorry. I was way ahead of myself there. Okay. So we need to define a node for our billing operation. Say define handle billing. This is going to be our billing node. Say state, support state. Then inside here, we're going to add a print statement so that we can know that we're in our billing operator, because if anything has to do with billing, we have to know that we're routed to the billing node. And it will display to make us know that the billing handler is currently handling the request. So it's a billing handler. So processing billing query. So once we have this in place, we then need our prompt and LLM. A simple LLM is going to do this operation. We don't need to augment it with anything. But first, let us get our prompt. So prompt pasted. And here it says you're a billing specialist. Handle this customer query. We get the customer query from state. And it says provide a helpful response that references billing policies and procedures, offers to check the account details, provides clear next steps, and mentions relevant payment options. And it says keep it professional and reassuring, because this is money issues. So yeah, you need to really keep it assuring or reassuring. So once we have our prompt, we can say response equals, then use our LLM. Like I said, we don't need to augment our LLM. We just need to generate content and freeform content. So going to pass in our prompt to that. Say content. Then we can return back into our state object. Say response. For response, we can just return our response here. Then for tools used, we'll just assume some tools. So let's say we used our billing database and our payment processor. So we also kind of queried our payment processor to know that, or to inquire from them about this particular transaction that the customer is worried about. So yeah, that's our first handler, our billing handler. So we have that in place. The next handler is for technical issues. I'm going to just copy this top section so that I don't have to type it over and over again. Just copy it and edit it. So this will be handle technical. Handle technical, and this will be the technical handler. Then let's just replace this with something technical, like let's say spanner. Okay. Or techie. Ooh, that's kind of jumped here. Okay, so we have our technical handler. And the next thing we need to do is also get our prompt, and our prompt is going to contain the instruction for handling the technical issue. Then we pass it to our LLM. Also, this LLM does not need to be augmented, so we can just use our plain LLM, because all we want to do is generate a response email. So I'm going to grab the prompt and paste it here. Then we're going to say response equals LLM.invoke. Pass on the prompt, get the content, and then down here we can say technical handler response generated. Did we have that in the billing stuff? Oh yeah, so we need to know that it's done. So here I'm just going to put the one for the billing handler. So like I said, this helps us a lot to know how the process is flowing. So here I'm just going to say billing handler, so response generated. So in the same vein, I'm going to come down here, do that for the technical handler, and then we can simply just return stuff back into state. Response will be response, And tools used. Let's make up some tools. So let's say we interacted with the knowledge base. Definitely for technical issues, that is necessary. Then we also use the bug tracker. Then we definitely queried our system logs. So those are the tools that we used. So that's good. Now I'm going to be doing one more thing to further speed things up. So let us copy this entire handler so that we just get to replace the name, the prompt, and just a couple of things. So the next one is going to be our refund handler. So I'm going to say undo refund. Undo refund. This will be a refund. Let's put a money bag here. Money bag, money bag, money bag, money bag. So money bag, yeah. So undo refund, here too we put refund. So yeah. So we just have that for our refund. This will be refund too. Refund query. Let me make sure that I've done that for technical. Okay, I haven't. So technical handler. Okay. So everything here changed to refund, refund, refund. Then we need to get I'm going to switch this prompt. I need to switch this prompt to a refund prompt. So let us do that. So for refund, I'm just going to switch this prompt from the technical to the refund prompt. And it says you are a refund specialist, handle this customer query. This is a customer query. Provide a helpful response that explains the refund policy clearly, outlines the refund process and timeline, asks for necessary information, order number, reason, etc. Shows empathy and understanding. Be empathetic and solution focused. So we do that. We generate our response. We say that it's generated. Then tools used. We queried the order database and also checked our refund processor, which is a subset of our payment processor. So our refund processor, we check that. That might actually be an agent. Cool name for an agent. Refund processor. So yeah, we have that. And for general issues, I'm just going to bring the handler in and explain. So to save some time, I'm going to paste that in. Very similar structure, but for you, it might not be this similar. So you want to make sure that you are making sure that each handler is tailored to its function. So undo general issues, undo general handler, processing query. You see with the information icon, just general stuff. You are a general support specialist, undo this customer query. Take our customer query, and it says provide a helpful response that answers their question clearly, provides relevant links or resources, offers additional help if needed, suggest related features they might find useful, and make sure that you're friendly and informative. So give a lot of details. Then we generate the response. We say that it's generated, and we contacted the knowledge base and the FAQ database because it's an information heavy request. So we have our handlers in place. We have all our handlers in place. And the next thing we need to do is how are we going to route from this router, our classifier query node and our router node, to these guys, to these four guys based on the request coming from the user. And like I said, we need to create a conditional edge. We need to create a conditional edge. So we're going to be writing a conditional edge function that can return any of the categories based on the query category. Good thing we've named the categories with exact names, and we can always return that with the query category because those are the names we are also saving into the query category from the classifier router. From the classifier router, those are the same names that we are using across board for each of the categories. So let's define our function that will route our query. This is actually the function that is performing the routing work. This is the function that's performing the routing work. Sometimes you can do your routing directly in the router node, and do directly with router node with something like command. You can use the command API to do that, but let's just be more explicit and dedicate that to a separate function. So this function is going to take in the state, which is going to be of type support state, and it's going to return a literal. A literal which can be of different types. So the literal can be of any of our types, which is billing. It can be technical. I'm just hope I'm writing those correctly. Then we have refund. We have refund, and finally we have general. We have general. So those are the literal strings you can return. And here we're just going to print to show that our routing operation is going on. So I'm going to put an F string here. Have a part emoji. Oh, let's say route. Yeah, so something like this, and here we're going to say routing. So that know that the routing is going on. Directing to state query category. Directing to state query category handler. Dub. Put a new line there so that we can know that the routing is going on. And here all we need to do is return the state query category. Query category. Because we have already told our structured output to use these names. So it's just going to return any of those names. It's going to return any of those names in the query category. And that's what we're going to use to route to our handler node. So we have this here. We can start building the graph. So builder equals state graph support state. Then we add our nodes. This time we're going to be adding our nodes with specific names. We're going to be adding them with the names of our categories. Yeah. For classifier query, that's fine. We're just going to give it the same name as the node function. Then for others, say builder.add node. The first one we're going to be adding is billing. And billing is going to be handled by handle billing. Let me copy this. Next, we're going to be handling technical. And that is going to be handled by the handle technical function. Oh, I should have copied this a bunch of times. So, yeah. So, we have refund next. Is it refund or refunds? Let's make sure. Refund. Refund, yeah. And the classifier is refund, okay? It's singular, not plural. So, refund is going to be handled by handle refund. And technical, or rather, general, is going to be handled by handle general. General, handle general. Perfect. So now we can start building the structure of our graph using edges. The first one we're going to do is to get started from start to classify query. Classify query node. So we have that. Now we need to move conditionally because from classify query we need to route. So we're going to say builder dot add conditional edges, and we'll say we want to go from classifier query. Then next is the function that is going to return where we want to go to, which is route query. And then we're going to give it a map of locations to go based on its return value. So if you return billing, go to the billing node. If you returned technical, just going to be copying at this point. If you return technical, go to the technical node. If you returned refund, go to the refund node. And finally, if you return general, please navigate to the general node. So that's good, but we need to terminate these guys. So we need to take all our nodes and make sure that they are terminated. Or you can route to the next thing. You can route to the next thing. You can route to another node that just takes over the process. Probably a node that will send the email, because here we're not sending the email, we're just generating the emails for these categories. But from these categories, instead of going to end as we will be doing now, you can actually go to the node that is going to use a tool to send the email itself. So say end, billing end, and let's just copy that a bunch of times. Billing end, technical end, refund end, general end. Good. Awesome. So now we can compile our graph for use. So graph equals builder.compile. Builder.compile. So we have that in place. And I'm going to bring in a bunch of prompts for different use cases so that we can test them out. One for billing, one for technical, one for refund, and one that is just going to be general. So let's paste those in. Our example prompts, we have a billing prompt, a technical prompt, a refund prompt, and a general prompt. The billing prompt says, I was charged twice for my subscription this month. Can you help? But let's just test them one by one, and from there we will be explaining what the prompt is saying. Let's say result equals graph.invoke. Customer query is going to be our prompt. For now, let us give it billing. Query category empty. Response empty. And tools used empty. Then we can come down here and print our final response. Print, have some demarcation there, let's say 70. And down here we can say print final response for restate, no. Final response for result, query category. So we know the category that this response is for, query category. Let's make it uppercase so that can just flow with this screaming header. So we have that. Just paste this down here. Do we need this F? We don't need it here. Get this down here. Then we can print the response. So result, response. That's the email that is going to be going out to the user. And just so that our tools used section is not going to be wasted, let us print out a more detailed report by talking about the tools used. Let's get another spanner here. Let's say spanner. Tools used here will then be, let's create a join statement that is going to concatenate all our tools and make with a comma. Yeah, comma separated. So say join results tools used. Yeah. So we have all this in place and we can run our code now. We can run our code. Yeah. A lot has been done. We created our router. We give it a structured output, and the LLM that processes the request is using a structured output. or rather is augmented to produce a structured output so that it can give us the exact query category to navigate to. Then we create the handlers. We have our routing logic here, and we added our conditional edge to route to our nodes. So now we're giving it a billing query, and let us see what it will do with it. You can say Python O2 workflows O210 routing.py. Let's hope everything goes well because we did a whole lot of typing. Hit enter. So analyzing customer query is a billing request. So routing to billing handler, billing, processing the query, and boom, done. Let's take it from the top. Where did we run? Okay, we ran it here. So the router says it's analyzing the customer query. It then gave us the analysis result. The category is billing, confidence is 0.95, really high. Reason is because the query specifically mentions a billing issue that is being charged twice related to a subscription. The customer's primary concern is about incorrect charges, which falls under the billing category. And that is based on the prompt that we gave the classifier. We instructed it on issues that fall under billing. Then it says routing to billing handler. Then the billing handler is processing the query, is generating it, and then we get our final response, which is the email. The subject is assistance with duplicate subscription charge. This is where the customer name goes. This is something we can always feed in dynamically from a long-term memory. Say thank you for reaching out to us regarding your billing concern. I apologize for any inconvenience, blah, 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 standard stuff. And says, please let me know if you'd like to proceed. I'm here to assist you with any further questions or concerns you might have. Warm regards. Then you put the full name, your position, that's the person handling the request, which you can also query from long-term memory, from Postgres or any database that is used, and then put in your company information and the information of your staff that is handling this request here. And it says for tools used, we use the billing processor and the customer and the payment processor. That's the billing request, neat and clean. Let's try a technical issue. So technical. This says the app keeps crashing when I try to upload files larger than 10 MB. So let's replace this with the technical prompt. Pull up the command line once again and run this. So analyzing the query is technical, high confidence. It's going to the technical handler, drafting the email, and very soon we should have the output. And boom. And boom. Now we'll see this. It's kind of formatted in Markdown, I guess because it needs more structure. It says, I'm sorry to hear you're experiencing issues with the app crashing when uploading larger files. Let's walk through this together to identify the problem and find a solution. Here are some troubleshooting steps you can follow. So it says update the app, check internet connection, clear the cache. Then if it's iOS, do this. Device storage, test with different files. If it's Android, it has some specifications too for Android. Then try to ask some clarifying questions in case you still couldn't fix all this. So if you can answer these questions, probably there will be context for providing a better solution. Then also it suggests a workaround. If the issue persists, consider breaking your files into smaller chunks below 10 MB if possible. This can help mitigate the problem while we work to identify a permanent solution. So you see, this is real life. This is something that you can deploy behind the fast API endpoint, and it will serve as your customer service responder. But you need to really ground it in your context. You can't just use it like this. You have to ground it in your context. We have a whole section on persistence and memory, so all that you can understand how to ground your systems in your own private knowledge, in your domain knowledge, so that it can answer questions based on the service that you are rendering. So yeah, we've tested technical. Feel free to test others. Test refund, test general, and tell me what you found out. Tell me what you found out. But I must confess, even though this was quite long, it has been quite fun.